In this tutorial video, I will guide you through setting up your Stable Diffusion XL SDXL Kohya Training Notebook on a free Kaggle account. Here is what you will learn. How to select the correct Kaggle notebook settings and start your session. Steps to install and initiate the Kohya Graphical User Interface Stable Diffusion Trainer. Setting best parameters and configurations for SDXL training with Kohya on a free Kaggle notebook, utilizing dual T4 GPUs simultaneously. Simply load my pre-shared configuration and click Prepare Dataset. Adding new data to your Kaggle account as a dataset for use in your session, like training images. The types of training images to use in your dataset. A new training approach. Instead of epochs, use a higher repetition count and save checkpoints based on step count. How to calculate checkpoints saves every n steps, estimating the total number of steps your training will take. Downloading saved checkpoints or files directly from the Kaggle working directory. Uploading generated checkpoints to Hugging Face from Kaggle or from other cloud services such as Google Colab, RunPod, and AWS. Quickly downloading checkpoints from Hugging Face using a browser or wget. Switching your Automatic1111 Stable Diffusion Web UI to the development branch. Finding and using amazing promptless PNGs. Installing and effectively using the After Detailer extension for automatic face and painting to enhance image quality, including specific face improvements. Comparing checkpoints by using XYZ comparison to identify the best trained model. Correct Automatic1111 command line arguments for using SDXL on low-end graphic cards for image generation. Installing TensorRT for faster image generation and improved quality.
So as usual, I have prepared an amazing GitHub Readme file for this tutorial. Follow this tutorial while this file is open. I will update this file if it be necessary. We will begin with logging into our Kaggle account. If you don't have a Kaggle account, register it from here. It is for free. After that, log in and make sure that your phone number is verified. Otherwise, you won't be able to use GPUs that Kaggle provides us for every week 30 hours, and it is amazing. So this is my Kaggle account. I am logged in right now. So as a next step, go to this link to download the notebook file that we are going to use in this tutorial. You can download it from here, version 9. Alternatively, which is even better way, go to the very bottom of the post, and in here you will see the attachment here. Downloading from this attachment is usually better. So we have downloaded our notebook file. Then click create icon here, click new notebook. Then go to the file here and click import notebook. Click browse files. Select the downloaded notebook from your downloads or wherever you have downloaded and click import. Then the notebook will be imported. Click X to close it. So this will be your notebook. Before starting, you need to make sure that your accelerator is selected GPU T4 X2. This is super important. Turn on GPU as you have seen right now. Then you can also select persistence. If you select files only, it will try to recover files, but this will make it work very slow, extremely slow. I don't suggest it. So when you are going to do training, you should be available until training completes. Then once the training completed, you should upload your models into the Hugging Face or download them into your computer. Uploading to Hugging Face, which is I suggest you to do. Then make sure that internet on is selected. Once you have made those changes, you need to click this button. It will start the session. Once the session started, you will see your hardware when you click here. Recently, Kaggle did a huge upgrade to the RAM they provide for free accounts. Now it is 29 GB and it is amazing. And we still get two dual GPU T4 with 15 GB VRAM having each GPU. They are amazing. Then all you need to do is click this cell. Once this cell is selected, you can click this icon or this icon. Let's click this icon. Wait until this cancel run disappears. So currently it will execute this cell and install everything automatically for you. This installation may take a while, so patiently wait. While installing, you will see the installation messages like this. Just wait at the end here. Once the setup has been completed, you see there is no cancel run anymore. There is no executing cell, and you will see setup finish it here. After that, whether you are training a woman or whether you are training a man, you can execute this cell to automatically download them and extract them. These are the latest regularization images that I have prepared for you guys. Since I'm going to train myself, it is going to a man dataset, so I click this cell. It will download and extract all the man dataset automatically for me. This dataset is prepared by me by spending days, literally days, and I am providing all of them to you. So when I enter inside the 1024 folder, 1024 pixels folder, you see they are even sorted by the face quality. How did I calculate the face quality? I used the very best algorithm available to rank the faces among different images based on the sharpness and focus of the face. You see in each image, the face is extremely clear, very high quality, and the reason why I did this is and sort them with a specific naming pattern as you are seeing, because the Kohya script will use the very first images that you need to use during your training, which I will explain how many will be used. So using these regularization images, classification images will improve our training significantly. This is the very best regularization classification images dataset that you can find. It is manually prepared by me. So the extraction has been completed. As you are seeing right now, our classification images are ready. Then as a next step, we are going to do a something special thing to run the GUI on the Kaggle notebook. Unfortunately, the Kaggle is not allowing to use public radio sharing anymore. Therefore, we are going to use a specific way. So first, click the link that you will see on your screen, read the description and the steps, get your authentication token, copy it, then paste your authentication token where you will see your token here. Then execute the cell. Whenever you start your GUI, you need to execute this cell, so it will give you a link here that you will see on your screen. Open it and just wait before clicking visit site. Then we will execute this link. This will also download the very best SDXL DreamBooth configuration automatically for you, which is created for Kaggle. With this configuration, we will be able to do full fine-tuning, full DreamBooth training of Stable Diffusion XL SDXL for free on Kaggle, which is amazing. If you had used the paid services, you would get much lesser quality and you would pay huge amount of money. However, I am bringing all of this to you for free so that you can use that. I have made over 100 full trainings to find the best hyperparameters for Kohya to do Stable Diffusion XL SDXL DreamBooth training. So you will have all of it. After this cell executed, you will get this screen. Then go to the other link that we have opened and click the visit site. And now you see we have loaded our Kohya GUI as you are seeing right now. Then we will begin with loading the configuration file. So click here, return back to your notebook, and when you go to the output folder and refresh it by clicking here, you should see the configuration. Yes, we see the configuration, Kaggle SDXL DreamBooth best JSON. Click this here to copy file path, then paste it here, click load. It will load the very best configuration for you. All you need to do is just dataset preparation, nothing else. So to be able to use your training images, you need to first generate a dataset in the Kaggle. So click this icon here. It will allow you to upload files. Click browse files. Go to your training images wherever they are. My training images are in here, and this is my training images dataset. They are all 1024 pixels exactly. This is not a very good dataset. Why? Because I have repeating backgrounds and I have repeating clothing. This is a decent dataset but not a good dataset. I have different distances as you are seeing right now, close shot, mid shot, and I have different angles. I don't have different emotions. If you want to have different emotions in the output, you can also add them. So this is my medium quality dataset. Hopefully I will make a much better and bigger tutorial. I will explain all of them, so stay subscribed. So I select all of them with Ctrl A and open. I have to enter a dataset title. When entering a dataset title here, make sure that you use English characters and no spaces. My train images, whatever the name you want to give. This is private, so no one else will see them. Click create. They will get uploaded into my Kaggle datasets. If you want to use anything with a Kaggle notebook, you should make a dataset first. Whether they are models, whether they are images, whatever they are, or whether they are a configuration file. And now you see I have my dataset here. If I do training again, I don't need to re-upload. When you click add dataset and when you click your datasets here, you will see it. And when you click this plus icon, and they will get added into your running notebook session. So my dataset is added now. I click copy file path and I paste it here into training images. I will train up to 100 repeating. And since this is a dual GPU, it will be total 200 epochs. Now the epoch calculation is really confusing at the beginning, hard to understand. One epoch means that all of your training images are one-time trained. Since we are going to do training with dual GPU, at one step we will train 2 images. Therefore, with 100 repeating, we will actually do 200 epochs. You don't need to think about it a lot because I will also show you how to get checkpoints and compare them, so you will find the best checkpoint. Regularization images, they are also here as you are seeing right now. So copy directory and put it here like this. Regularization images repeat 1. Instance prompt, it will be a rare token OHWX and the class prompt will be man. I have other tutorials. If you want to learn more about instance prompt and class prompt, you can watch them. They are all linked in the GitHub Readme file as you are seeing right now. So destination directory, this will be inside in our working directory in outputs like this. So everything will be saved here. Click prepare training data, copy info to folders tab. And now you see they are all ready. You can give any module output name. I will use my DB Kaggle. And you can see they are all copied here. Now we will be using more output folder size as you are seeing right now. The outputs arrived here after I click it refresh. However, since each checkpoint will be about 7 gigabytes, we don't have sufficient output folder space. So what we are going to do is we are going to save them into the Kaggle temporary models folder. So copy the path from here, go back to your Kohya GUI, go back to folders and change the output folders model path. Make it, how you should make it, you need to make it like Kaggle temp models because this directory has been generated automatically. So go back to here and change it to this. This is really important. If you give another name, it may not work because the models folder may not be automatically generated by the Kohya in the second time. So use this models folder. So the model files, the checkpoints will be saved into the temporary space of the Kaggle, and Kaggle provides us about 50 gigabyte temporary space available. You see from here, which makes roughly we can take like 7 checkpoints, but we will stop at taking 6 checkpoints to be sure. Okay, now the parameters. There is one parameter that you need to set, which is when you go to the advanced tab, save every end steps. Now you need to calculate this yourself. For calculating it easily, click print training command here and it will display how many training steps that it is going to take. Since I have 13 images, it is going to take 13 multiplied with repeating 100, 1300, divided to 1 because the batch size is 1, divided to 1 because the gradient accumulation steps are 1, and multiplied with 1 because we are going to do training with only 1 epoch, and multiplied with 2 because we are also using regularization images. So the total training will take 2600 steps and we will do total 200 epochs training. If I want to take 5 checkpoints, you just need to divide this into 5. So 2600 divided to 5, 520 steps. This is the step count and I need to get checkpoints, so 520 steps. With every 520 steps, I will get a checkpoint and I will download all of them. And after that, you can save your JSON if you want to use it later. Then you can download it from here if you wish. And we are ready. Then click start training and you don't need to do anything else. this training will start. First, it will cache all of the images that we are going to use, including the regularization images. The caching will take some time. It will also display you everything here. You see, it is going to fully load models into both of the GPUs. So it is not like we can combine the VRAM of the both GPU. And it will download the SDXL base model, and it will download the SDXL 32 precision VAE as well. So our models will have the best SDXL VAE already embedded. The download speeds of Kaggle is just amazing, as you are seeing right now. Then it is going to load the models into the VRAM after they are downloaded. You see additional VAE is loaded. I have prepared everything for you, so it is just super easy for you. You don't need to do anything. First it will cache latents, then it will start training. The training for 2600 steps is taking about 3.5 hours. When the caching included, it is going to take like 4 hours, which is amazing. Why? I will explain in a moment once the caching is completed. So the training has been started. You see currently we are getting 5.08 second IT, and you may say this is slow. No, this is actually a great speed. Why? Because currently we are utilizing dual GPU. Therefore, this is actively 2.5 seconds per IT. And on my RTX 3090 Ti GPU, I am getting like 1.6 seconds IT. So we are almost getting a free RTX 3090 Ti GPU from Kaggle for free every week, 30 hours. This is amazing speed. So the total training is going to take like 3 hours and 32 minutes plus 7 minutes are passed. So it is about 4 hours in total for training. So just wait and we will download all of the models after the training has been completed. You cannot close your browser while the training is happening. This is a limitation of free Kaggle. Therefore, your computer and browser has to be open during the entire training session. Currently, we are using 32.4 GB on our temporary disk. After checkpoints are generated, we will use more. So we will compare once the first checkpoint has been generated. The first checkpoint will be generated after exactly 520 steps because we did set it like that, and currently we are at the 108 step. So the first checkpoint has been generated. You see exactly at the 20% steps because we have divided the number of steps that are required to 5. So we got our first checkpoint. This is its saved name, and you see the disk usage is now 38.9 gigabytes. And the training is continuing successfully. We just need to wait. Unfortunately, there is no way to download this model before canceling or waiting the training to finish. Therefore, we have to wait until the training has been completed to download this saved checkpoint. Since it is saved in the temporary folder, we are going to use the Hugging Face repository upload method, which will be super fast for uploading, and when you are downloading it will be also super fast. I will show in a moment after the training has been completed. Alright, the training has been completed. It took 3 hours and 44 minutes. However, we have an issue. You see currently we are using 77 gigabytes of temporary memory and they are giving us only 73 gigabytes of hard drive. Therefore, we need to reduce number of saved checkpoints. We saved 5 checkpoints. However, since it was exactly as the 20% of the steps, it also saved the last step 2 times. So how to prevent it? Instead of using the exactly divided step number, increase this by 1 step. So make it 521 steps. So you will not get the last step saved checkpoint. You will get the end of the checkpoint that the model generates. Therefore, remember when you are watching this tutorial, make the step count 1 more than the division of the 5. Alright, so how are we going to download the generated models right now? There are 2 ways to download them. The first way is moving them into the output directory and downloading from there. To do that, we need to first cancel run, which is the running instance of the Kohya GUI. So I will cancel run. Okay, now I can execute the other cells. The first cell that we will execute is this cell. This cell will list the directory of the temporary models folder where we have saved our models. And these are the models that have been saved as you are seeing right now. So we can download them one by one. Let's say we want to download the first checkpoint, which is this one. Copy its name, change the name here like this, execute this cell. After you executed this cell, this model will be also copied into the Kaggle working directory. We will see it in a moment after this cell execution has been completed. The temporary disk space of the Kaggle is really slow compared to the output folder's hard drive space. Actually, there was once a bug which made it much more slower than the output. By the way, it looks like it is also counting the output folder in this total disk space utilization. Okay, it is almost completed. Yes, it is completed. Now refresh here and you see the save tensor file is also here. So you can click these three dots and click download. When you do this, watch the address bar of your browser. If you start multiple downloads, it will ask you allow multiple downloads from kaggle.com and it will not display the download status. So how you will know the download status? You need to open your task manager, go to the performance and check out your Ethernet. So you see currently it is downloading with 200 megabits per second. Once the download is completed, I will see an immediate download from my browser. So it will be immediately saved into the downloads folder. But I am not suggesting to do this methodology because you have to move every file one by one and you will not see the progress of download. For example, if I want to also download the second checkpoint, I have to first remove this first checkpoint from the output folder by using this. This will delete this model from here, so I will be able to repeat the first process and move the second model into the output folder. So what I suggest you to do Hugging Face upload methodology. To do that, you need to have a Hugging Face account. The join link is here. You can click this join and register. Currently, I will also register to show you. So this is the account that I am going to use for registering. I read in a password, click next. It will ask you username and other stuff. So let's make this account as video tutorials. Let's say my username. Okay, other things are not important. I have read, create account. Okay, it is first asking me human verification. This may be an interesting issue for you, so let's make it like this. Okay, it was success and we got our account. We need to verify our email, so let's verify it. Okay, it is verified. So then you need to go to the new model. This is important. Click new model, give a model name, my checkpoints, whatever the model name you want. You can make it private or public. I will make it private so no one else will be able to see or download it. So this will be my username and model folder. Click here to copy it. Return back to your Kaggle notebook. Change the repo ID from here. The folder path is this folder where I have generated and saved the models, so you don't need to change it. Then click this icon first. It will ask you to enter your token. So how will you generate the token? When you go back to our GitHub Readme file, you see there is a tokens link. Right click and open it in browser. Alternatively, you can click here and you can go to settings. In the settings, you will have access tokens. Click here, click new token. Make sure that you have selected right. This is super important. And let's say upload. Any name you can give, generate token. Copy the token from here. Go back to your Kaggle. Paste it, click login, and you see token is valid, permission right. This is super important. Then set the repo ID as I said from here and click this play icon. So this will upload all of the models into the Hugging Face repository that you have made permanently, and then later you can download them as you wish whenever you want with ultra fast speed. I thank a lot the Kaggle and the Hugging Face from here. They are hugely contributing to the machine learning, to the AI space. Their importance are significant. So I thank them a lot. I suggest you to also follow this strategy to upload. In the first run, it may take a while because it is first calculating the hashes of the models, then it will start uploading. You see our model download is also just completed after downloading. And now when I check my Ethernet, you see the speed is dropped like this, the internet usage speed. So as I said, you can move each file one by one and download them. Alternatively, you can upload all of them to the Hugging Face. Let's just wait a little bit. So after you uploaded those files into the Hugging Face, where they will appear when you go to the profile, go to your models checkpoints here, go to files and versions, they will be here. And this will be only visible to you because it is set to private. No one else will be able to access them. Let's just wait a little bit more. Okay, meanwhile waiting it, the below is for LoRa training. I will search for better configuration for LoRa training, but I don't suggest you to do LoRa training. SDXL DreamBooth is much more stronger and better than the LoRa. So if you really need LoRa's, then you can use the Kohya GUI version to extract LoRa's out of the fully trained checkpoints, fully trained models, and they are much better quality than the LoRa training itself. Hopefully I will make a video about that too. You can use your own computer to extract them. You don't need VRAM actually for doing that. So it will be hopefully a topic of another video. I will search for the best LoRa extraction settings and share them with you. I will also search for best LoRa training configuration as well. But this is the configuration I have at the moment. When you download this notebook, you will have that. So on our channel, I suggest you to watch these two tutorials as well if you wish to learn more about using the Kaggle, using the Automatic1111 Web UI on a Kaggle, and watch this tutorial to learn more about LoRa training if you prefer. Hopefully new tutorials are coming too, so please subscribe to our channel. You won't regret it, believe me. The upload still didn't start. I think it is taking time to calculate hash all of the models. We can see the CPU usage and the RAM usage because it is working right now. So from these uploaded models, actually this final file, you see it is named like this, is equal to 2600 steps model. So these two model checkpoints are actually duplicate. As I have explained it, to prevent that, we need to make minimum number of steps to generate checkpoint is 1 plus of the division. So calculate the number of steps, multiply it with 5 and add 1 step. So the upload has been started. You see the upload speed, it is huge. Currently it is uploading 5 models and the total upload speed is like 100 megabytes per second. So it is equal to 800 megabits per second. You see the speed, it is huge. Once these uploads have been completed, we will download them from the Hugging Face as we wish. So all of the uploads have been completed. You see it took total like 5 minutes and not more than that to upload all of the models. So you see we got the link here where the uploads have been completed. Let's refresh our files and versions and you see all of the files are here. We already have downloaded this checkpoint. Now I will download the other ones too. So click this icon and it will ask you where to download. So I will download them here. Let's download all of them. Why I am downloading all models? Because I will do a checkpoint comparison. So instead of these 2600 steps, I am going to download this file. This is the, which one was the latest? So if we look at the checkpoints, yeah, the last checkpoint is mydb kaggle.save tensors. So that is the one we are going to download, which is this one. This is the last checkpoint. This one is equal to 2600 steps. So this model that contains 1 step shouldn't have been generated. I will tell this to the developer for fixing. And our last checkpoint is named like this. So let's also download it. All the files are getting downloaded as you are seeing right now. Let's see the download speed. You see it is 430 megabits per second and my maximum download speed is 500 megabits. So it is almost maximum. Okay, now we are completely done with the Kaggle. So we don't need anything else from here. Then you can terminate your session by clicking here and start using your models. Now I will show how to do a checkpoint comparison to find the best checkpoint among all of the saved checkpoints. So let's terminate this. And I still have over 19 hours This week, when I hover my mouse here, you see it shows when my quota will be reset. So all of the downloads have been completed. I am going to do a fresh installation of Automatic1111 Web UI. Let's go to our automatic installer list. In here we have automatic Windows installer, which is automatic installer for SDXL. So let's open this link. And we have automatic installer but file here. Let's download it. Where should we install? I will install it into my F drive. Let's say test. Let's enter inside test and let's double click. More info around anyway. It is cloning the Automatic1111 Web UI. This will install everything automatically for you. It skipped the download SDXL.py file because it doesn't exist. We didn't download it. I will move my models into this folder. So they were inside my downloads folder. Let's refresh and let's cut all of the downloaded files. This is from yesterday, not today. And let's move them into the models folder. If you don't have a GPU having computer, then you can follow my how to use Kaggle for Automatic1111 Web UI tutorial, and you can upload these models to your Kaggle with just wget into the models folder and use them. So it is very easy to upload them once you have them on your Hugging Face account. If you want to use these with wget command, all you need to do is right click, copy link address, then entering inside the models folder wget this link, remove this part, and that's it. However, for this to work, you need to make this public. So when you are downloading into your Kaggle or Google Cloud or Rampot, make it public temporarily, then make it private again. And it will allow you to quickly download models. Alright, automatic installer is installing. Our models are here. These models have the embedded VAE, the best VAE, so we don't need a secondary VAE for this to work. Okay, the installation has been completed. The Stable Diffusion Automatic1111 Web UI automatically started. We can see the checkpoints here. There are several things that I do. First of all, go to the settings tab. In here, go to the user interface. In here, make VAE from here like this. Apply settings and then go to the extensions. Click available, load from, select after. Search for after and install after detailer. You see this extension, click install. And you can watch the status from here. So you see my automatic installer installed everything for me. What you need for this to work, you need to have Python installed. You see my default Python is 3.10.11. And plus to that, you need to have Git installed. When you type Git, you should get a message like this, Git. Alright, the Web UI is getting reloaded. It is installing the necessary requirements. Everything is installed. After this, go to install tab, apply and restart the UI. So you will have the newly installed extension. We also should add -- no-half-vae to our Web UI. So it is here. I am editing Web UI -user.bat file. So let's add no-half-vae. And after that, I will restart the Web UI. So let's go back to Web UI and start again. This is how you start the Automatic1111 Web UI. I am starting with Xforms and no-half-vae. After detailer is initialized, I will make this none, so it will use the embedded VAE. I prefer to use DPM++ 2M STE caras. This is really important as a sampling method. And first we need to decide which checkpoint is best. But before start, there is one more thing that I will do. There haven't been any significant updates to the Automatic1111 Web UI for weeks, actually for months. When we go to the development branch in the Web UI GitHub repository, we will see that it is 367 commits ahead. Therefore, I will update the Web UI branch to the development branch. So how will we do that? Let's close this. Let's go back to our installation, start a CMD like this and do git checkout dev. Now we are at the development branch. Let's also update it, git pull. And now we are at the latest version of the development branch. Then let's restart the Web UI like this. And I will use the amazing prompts that I have found after a lot of research to do XYZ checkpoint comparison testing. The prompts are in this post. Let's click it from here. You see it is under suggested resources in the GitHub Readme file. This Readme file will be in the description of the video. And you see there is version 1 prompt list.pdf, or you can also download the images and use the PNG info. Actually, let's do that. So these are the images. They are getting downloaded. Let's open, extract, and the images are here. So now I can use PNG info. You can alternatively also download the PDF file and use that. So the prompt images are here. I have gone to the PNG info tab. Now I will just drag and drop the image that I want to use as a checkpoint comparison testing. You see the prompt images are here. Which one we should use? Maybe, yeah, let's use this one perhaps. This is a good one. Let's see the image. Yeah, this is a decent image. By the way, with the very best configuration that I have on Patreon right now, I can get even better than this image. This image has been generated without text encoder. Unfortunately, the Kaggle performance is not as good as you are doing it in your computer with 24GB GPU or on RAM pod, but still we will see the performance of the Kaggle training. I will use sampling steps 20. You can also use 40. It will be a little bit better, but for this demonstration, let's use 20. You see, this is the rare token that we did training OHWX man. If you are training with woman, you need to change this woman or whatever the rare token and the class token you have chosen. Don't forget that. Width and height has to be 1024 to 1024, or if you have done the training with a different resolution, then you should use it. Let's make the batch count 9. Let's make this random seed. Let's uncheck this VAE because we have used the best VAE. Now these models have the best VAE automatically. You don't need any additional VAE. Let's enable after detailer. You see the prompt is also here. Let's make the detection mask only the top K largest one. So it will only inpaint my face. If there are multiple persons in the image, they won't get inpainted. And I will also change the inpainting denoising strength to 0.5. It is already like that. You don't need to change any other options if you are not sure. The default are good. Photo of OHWX man is the prompt. Let's make the XYZ plot. So this is how we are going to do checkpoint comparison. We go to the very bottom. We select the XYZ plot from here. We select the checkpoint name from here. It will list the checkpoints. I will start from the least training steps to the latest training steps. By the way, 2600 and the very last one are same. I also compared them. So I will select the 2600, or maybe let's select the last one. It shouldn't matter. And let's also make the grid margins 50. All right. So this is it. Now we are ready to do testing. At every checkpoint, it will generate 9 images with these prompts. And it will also do face inpainting to improve the face quality. CFG scale is 7. And let's generate. Okay, the generation has started. With this way, we will compare the outputs of each checkpoint. Then we will decide which one of the checkpoint is looking best. All right, we got the images. There is one more thing that I want to mention. If your GPU is not good, then you should edit Web UI user.bat file and add here like --met VRAM. If it is still working very slow or not even working, then you can add low VRAM. This will make the application work slower, but it will work. So try --met VRAM first, and if still fails, add --low VRAM. Don't forget that, but I don't need them to add right now. Okay, so we click this icon, it will open the outputs folder like this. Let's go to the text to image grids, and in here at the very bottom, we will find the very last grid. Okay, so we got the images. Let's look at them. Here we see the images. The first checkpoint is looking very bad actually. Let me also open one of the images from the training dataset so we will have a better comparison. Let's go to the pictures where my training images were. Okay, here. For example, let's use this one. Okay, now we will have a better idea. You see, the first checkpoint is not good. Then let's look at the second checkpoint. By the way, I am using paint.net. So this is a free image editor. The second checkpoint is also not looking good. Let's look at the third checkpoint. The third checkpoint is very decent. You see, you can get very good images by generating more images. As you can see, the realism is really good. So not all the images will be super good because we are doing a free training. We don't have a 24 gigabyte, but very decent. And my dataset is not good, as I said. If you improve your dataset, you will get better results. I am using this at best medium quality dataset, as I said, so that you can get a better dataset than this and collect better images. Also, some images will look according to your other images, not the very best looking one. So improve your dataset to get better quality images. Okay, this is the third checkpoint, 2080 steps. Actually, it is being effectively 4060 steps because the batch size is 2. Yeah, we can see the results. The head of the shape type of the head is broken for some reason. And this is the last checkpoint. Yeah, the head is broken. I think it is a little bit overtrained. So among these, I think the best looking one is the third checkpoint. Maybe if we had a checkpoint between these two, it would be better. So you can do multiple trainings and aim different checkpoints to see which number of steps are best. I think it can be between these two on these settings. But you can also do more checkpoint comparison test with more images, not with just single prompt. So let's select another prompt from our downloaded prompts. Let's see which one should we try. Okay, let's try this prompt. So I will copy the positive prompt and I will copy the negative prompt. The rest will be same, so let's hit generate and see the results. Okay, the second test has been completed as well. Let's open the image file and let's look at each checkpoint. Okay, let's see. First, second, third checkpoint, fourth one, and the fifth one is here. Yeah, the fifth one has faces really broken for some reason. Some of them are looking good though. I think the third one is still looking the best. Probably from third checkpoint we can get really good images, but I would say that something between third and fourth would be better if we had more frequent checkpoints. So perhaps we could reduce the number of steps and have more frequent checkpoints. So to get good images that we would like, what can we do? We need to generate a lot of images and find the very best ones. And we need to generate fast. For generating fast, we need TensorRT. For TensorRT, I have this auto installer in this post. Let's download the TensorRT installer, this bat file. I also have a full tutorial here, so you can also watch this tutorial to manually install yourself and learn everything about it. Let's move this into our repository. So I will quickly install it into my Stable Diffusion Web UI. Just double click, more info, run anyway. It will install the extension and also the necessary code and library for me automatically. Then I will generate the TensorRT model quickly. Okay, download has been completed. Let's restart the web UI. I am in the development branch. That is really important. Okay, TensorRT installed and started. Let's enable the UNet from user interface. UNet from here, SDUNet, apply and reload UI. Since I think that the third checkpoint, which is 1560 steps, is best, I will generate a TensorRT for that one. To do that, first I will select the model from here, as you are seeing right now. Once the model is loaded, I will use 1024 batch size 1, but I will change the optimal prompt token count to 225. So if the prompt is long, it will not cause any errors. Let's export engine. It will export the engine and do everything for me automatically. Let's see if there is any error. Okay, we have an error at somewhere. It says self min batch size, self max batch size, assertion error. Okay, maybe we don't need to use static shapes since we are changing the prompt token count. Yeah, let's make it like this. Export engine. Yeah, you see, after I enabled the advanced settings, make the min prompt token count 75, optimal 75, and max 225. Now it is starting. This is really important. Watch this full tutorial to learn more about it. The tutorial link is here. The automatic installer is here. Okay, so the TensorRT file has been generated and saved into disk. Now we can generate images very fast, and I am going to use the amazing prompt list as a txt file from this post. Let's download it. Let's open all of the prompts like this. If you have a different rare token, just use Notepad++ and replace all of them as you wish for. Okay, let's copy it. Let's go here and let's select. And from the very bottom, select prompts from file or text box. You can upload or copy them. Let's upload the downloaded file like this. Alright, and let's enable after detailer, photo of OHWX man. For non-realistic prompts, these may override the style, but for realistic prompts, this will work very well. And for inpainting, I made it 50%. So this is being equal to 50%. Let's change the height and width, page count 1. Let's select the best sampling method. All right, everything is looking good. Then from SD unit, I will select the newly generated TensorRT file. And I will also delete the older generated images, so we will see the new generated images. And let's hit generate and see the speed. All right, let's open the command line interface to see the speed. Meanwhile, I am generating okay, we got an error, which is, let's see, maybe it didn't see them as a single line. So let's try with a single line first and verify the TensorRT is working or not. Okay, let's generate. Yeah, we have a problem. Multi-head attention forward name error. It is still trying to use all of the prompts for some reason. That is weird. Alright, let's restart the Web UI. Sometimes there might be some errors. It is not a very important issue. You will also get these errors. You can ignore them. Okay, accurate model are selected. Let's make the resolution. Let's try quickly. Okay, the image is getting generated. The speed is very decent. Now let's enable after detailer and change the everything to accurate settings. All right. Okay, let's try one more time with after detailer enabled. Okay. Okay, the speed is huge as you are seeing right now. It is really fast even though I am recording a video. Okay, face improved, but I can see the clothing over training. This is like my shirt in my training images. So you really need to improve your training dataset if you want the very best quality. Okay, it is looking decent. If you want to use high resolution fix, then you need to increase the resolution of the TensorRT that you have generated. Now time to try the prompts from file or text box. Now let's upload all of them. Insert prompts at the start or end, it says. So let's try like this. Let's delete the original image, original prompt. Okay, now it started generating all of the images. For some reason, probably due to a bug in the Automatic1111 Web UI, it wasn't working. Now it will generate all of the images very quickly and very amazingly. With this strategy, you can get perfect images from different styles and use the very best ones. So you see in that image there were multiple faces, but it only changed the single face. Okay, you see this face is also getting improved like this, but the quality is not at the 24GB training level with BF16. On Kaggle we are using FP16, and I think BF16 is working better than FP16 for some reason. I don't know, probably due to the precision of the weights, but the results are really good. You cannot get these results with Stable Diffusion 1.5 based models training. Of course, not all the images will be best, so you can generate multiple images and find the very best ones. You see, very decent image. You can even do high resolution fix by making a TensorRT for it. So each image generation is taking like 2 seconds to, with the after detailer like 5 seconds. It is taking like 5 seconds. I also have a tutorial for how to use Automatic1111 Web UI on a Kaggle. So by watching this how to use Stable Diffusion SDXL ControlNet LoRa's for free without a GPU on Kaggle, You can watch this tutorial. If you don't have a strong GPU, strong computer, watch this tutorial to learn how to use Automatic1111 Web UI on a Kaggle with super fast speed. Believe me, it is really working very well with the GPU that Kaggle provides. So you can do everything that we are doing on our computer on Kaggle for free, and we are getting very good images as well as this one you are seeing right now. Results are decent. I like them, and all of these are made with a free Kaggle account. We didn't spend any time. You see, this is decent. Okay, there is another one, as you are seeing right now, very decent. The model is performing decent. I think for free, these are really good. And you can try different prompts, improve your training dataset, change the number of steps that you did training to get the very best results. If you decide to use paid Google Colab, Kaggle or Rampod and have 24GB having GPU, our very best settings are shared here. These settings found after 100 plus full trainings. I just recently updated them yesterday. So you can download the 24GB text encoder JSON. It is the very best version, and do your training and get even much higher quality results and accurate images. But with even SDXL DreamBooth training on a Kaggle, we are able to obtain amazing quality images like this one. This is all for today. You will find all of the links and instructions that you need on the GitHub Readme file. I hope you have enjoyed. Please join our Discord channel and ask me any questions that you have or reply to this video. Our Discord channel is really important. You see, we have Discord online here. When you click this link, you will get to this page. Join our server. We have over 5,500 members, majority of them related to Stable Diffusion AI, generative AI. I am working on even more amazing tutorials. You can also purchase our Udemy course. You can follow me on LinkedIn. You can follow me on Twitter, on DeviantArt, on Sweet AI or Medium. You can support me with Patreon or buy me a coffee. I appreciate that very much. On our channel, you will find amazing videos. Click the playlist and you will find the playlists that I have. So I suggest you to watch the playlists that we have. Hopefully see you in another amazing tutorial video.